Welcome everyone to this online workshop organized by the EvoRoads project with the support and in partnership with the iDriving and Canva projects. So the purpose of today's workshop is to introduce these projects to one another, first of all, but of course also to you all in the audience today. Then to present the first results from the project as far as iDriving and EvoRoads are concerned, since Canva started a bit later. And finally, to have a discussion, to exchange views on approaches in relation and share best practice and insights that can be mutually beneficial. So the agenda for this afternoon is, first of all, an introductory presentation and presentation on the first results related to requirements from EvoRoads, which will be followed by a short time for questions in relation with the presentation. Anything unclear for you? For raising questions, by the way, you have a Q&A a menu in your interface, so you can do so in writing. But of course, you can also raise your hand and then we'll give you the floor if you want to ask these questions live. After which we'll have a similar presentation from iDriving, also followed by a short Q&A to clarify anything that wouldn't be clear on this presentation. And finally, we'll hear about the Canva project, after which we'll go to a discussion. And without further ado, I'd like then to give the floor to our first speaker for today, Ms. Angelina Despotopoulou. She's a senior software engineer and project manager for Frontier Innovations, and Frontier Innovations is the technical coordinator in EvoRoads. Angelina, the floor is yours, and I let you share your own presentation.
Thank you very much, Julie, for the warm introduction. Let me share my screen, just a minute. So, great. Thank you very much, everyone, for attending this presentation. I'm very honored to be here and represent our project. The purpose of, I will be presenting two sessions, actually. The one is the general presentation of the EvoRoads project, a rather short one. And then I will be presenting our primary results. This is the structure of today's presentation. We will start with the general EvoRoads project overview, as I mentioned earlier. We will be discussing a little bit of regarding the goals of our living labs, or the pilot sites, if you would prefer the term. And then we will be having, because we have been using this living labs approach as opposed to the more usual pilot approach. So I will be presenting what exactly we have been doing and in what way it is different. It is different in comparison to what you might know about pilots from other projects. Then we will be doing a very short break, let's say, from the technological aspects and discuss about the safety assessment framework, which is the first major outcome of our project. And then, depending on the time we have in our hands, I will be giving you some highlights regarding the technologies of the project and maybe the architecture of the project. If we do not have time, I will just be using those slides in case there are questions regarding on those matters, and I will present targeted diagrams from there. Okay, let us start with the project overview, the first part of our presentation. EvoRoads is a project that has started last year. We are currently in month 14. I suppose the participants of the present workshop, if you come from our sister projects, you're already very familiar with what the initial call was about. But to give you just a presentation with a description of the project with very simple words and not the more elaborate phrasing that we have on our website and on our official page. EvoRoads, it's a smart infrastructure platform that targets to enhance road safety by bringing advanced technologies together to work in collaboration for early detection of structural deficiencies in the streets and to support people who are doing maintenance on those on infrastructure on roads in order in a timely manner, which is very, very important. And as a vision, let's say, EvoRoads aims to contribute to Vision Zero, which is a global road safety initiative that aims to eliminate all traffic deaths and serious injuries. That is today the European Union has endorsed this initiative, and now it's among its primary goals. Some key figures about the project. We have 6 pilot locations hosting 4 different living labs. We will be analyzing those a little bit later. We have 20 partners from 10 European countries. As I mentioned before, we started last May and we are currently in our 13th month. We have just started the second year, so to say. And the slide says we will be having 10 key innovations. That does not mean that we will be testing 10 technologies. Let's say it's 10 families of goals, of groupings of technologies and artifacts and outcomes. This is our consortium. It's not a very big one, nor a very small one. From your projects, you may recognize several companies. Of course, Ertico is our project coordinator and our dissemination manager. And I represent, as mentioned before by Julie, Frontier Innovations, which is the technical coordinator of the project. But of course, this does not mean that anybody else is inferior to us. Nothing could be done with the dedication and the hard work from everyone, and which is always appreciated. Regarding now the countries we are targeting, which is let's say they have been chosen strategically, and I will be explained why. We have, as mentioned before, 6 pilot sites in 4 countries. We have we have 3 different cities in Spain. We have, as you can see in the map, we have Madrid, which is the capital, of course, of Spain. We have as a pilot site in Tarragona, in an area called Santa Oliva. And we have a road, let's say, not exactly a city, a big road in Galicia, which is the autonomous community in Spain, that it is right above Portugal. From Italy, our pilot city is Torino in Piedmonte. From Romania, we have a historical city that is called Alba Iulia. And from Latvia, we have the capital, Riga. Let us see why those countries are important and why we consider that they are a very good mix on what we were trying to do. Those that you can see on the screen are statistics provided by prepared by the European Union. The graph on the left is from 2023. The map on the right is from 2020. That So actually, both graphs show how serious is the problem of road fatalities and road accidents in several countries. And as you can see, two of our pilots, Romania and Latvia, are have very, very high percentage of a very, very serious problem, let's say, in road safety, at least as compared to other countries. I come from Greece. My country does not fare very better. I did not mention it to make them feel bad. We have Italy, which has a problem above the average, but has done significant progress and fares a little bit better. And then we have Spain, which is let's say they are the mature case. They are the safest in the assessment of all four countries, and they have been chosen so as to serve as an example, as to have in order to be able to benchmark the differences between a country that fares rather well with the countries that do not fare well. What is the difference between the three? And this is why we had this is why we have targeted those areas. This is how we could visualize our project. Of course, it's not a technical architecture of the project exactly. It's more the concept in a diagram. Unfortunately, I do not have the time to go in to explain each and every technology here and go into every plane. Of course, you're very welcome during the Q&A session to ask anything you would like, but we can address specific technologies, I think, in a subsequent webinar. From this graph, I would just like you to keep the main, the 6 axes as they are described there, that we have in the bottom our data, the various data sources that will be feeding our technologies and our examples. But they are, as you can see, they are road maintenance data. It's footage from cameras, footage from satellites, footage from drones, sensors on smart vehicles, on scooters, and there's information, general information and statistics from the municipalities. We have the safety assessment framework that I will be analyzing a little bit earlier in the third part of this presentation, which is briefly, they are all the criteria that matter, let's say, to safety. They are the criteria that you can use as metrics in order to compare a before situation and an after situation and see how well a technology fared in battling the problem of road safety. We have the axis number 2, which is our digital twin. In the sense that the digital twin, it's actually a component, it's a system, it's a platform, it's a software, but it also has, it's in a more general sense, it also contains the methodologies and the bibliographical research. Its scope is a little bit more wider. We have axis number 3 and number 4, which are our tools and technologies brought by the various partners in the technologies. They are algorithms, they are hardware, they are the equipment, the various sensors, the various cameras, everything, and they are the technological enablers, let us say, that we hope will bring us closer to our goal. And we have axis number 5, which is how we integrate all those solutions, because we will be having an integrated platform as far as this is possible. And I have separate slides in order to explain a little bit how this will happen, but I also remain open at your questions. Of course, this platform will be having some user interfaces, and of course, also part of this axis is also our is everything that we can consider output of the project and direct it towards the end users. And towards the European Commission. For example, it is not only something that a user can see on a dashboard on a map, it's also a policy recommendation, it's standardization, it's our safety criteria catalog being published in some academic papers, things like that. And of course, at the top of the diagram, you can see also our pilot demonstrators. And I think this is the general presentation of our project. Since there was a session here, I don't know if Julie, you would like to have a Q&A there. I do not see it on the.
No, we can directly go with the first presentation and then we'll take the Q&A then.
Perfect. I'm open, right? Okay. Thank you very much, Julie. We can start now with some highlights from our living labs. Of course, I will not have the opportunity to go through all of the requirements one by one that have been collected from the various living labs. But I will just give you a very on the top presentation of what each one is aiming to achieve. As I mentioned, we have Torino, a very historical and big city in the area of Piemonte in Italy, which aims to assess pedestrian risk exposure via sensor-enhanced crossings. One of them, you can see it in the picture. They would like to try to integrate onboard units and roadside units data for behavior analytics to see how they can what drives from the human side, let's say, what causes the accidents, what behaviors, and how those can be altered, what propositions can they do to the people to change those behaviors towards a more safer behavior, and to evaluate nudging strategies. Nudging strategies is exactly what I described before, trying to make people adapt a better behavior, and also evaluation of ISAD readiness. ISAD is infrastructure support for automated, stands for infrastructure support for automated driving. More or less, it's a scale that says how safe it's a road to be used by an automated vehicle or a semi-automated vehicle. And to analyze pre-intervention and post-intervention crash data for a risk profiling. This is research work, of course, that they will be doing with the help of the municipality of Piemonte. We have Galicia. Galicia will be testing their technologies and their business case in a particular a highway across the country, let's say. It's in a particular national road. This is the word I was looking. And what we're talking about a rural environment, as you can understand. It does not go. It joins to cities, but it does not go through cities. And they will be choosing particular spots that are of interest in order to. They will be trying to map rural connectivity via KPI-based probe VT tests. They will have, in other words, they will be having cars equipped with a driver who acts as the actor. And those cars will be having sensors in order to collect data on the goals I will be mentioning. They will be classifying road segments, and they will say those across the various levels of the ISAT model I mentioned before. They will generate real-time coverage heat maps, and they will say, okay, we have those various levels, which road part belongs to which level. This will be visualized through the map. We will be having SICAM deployment planning with network diagnostics. They will be seeing across those road parts how well how well the network coverage is, in more simpler words, and they will be validate, as I mentioned before, validate service availability thresholds to structure drive tests. Madrid will be testing we'll be testing two areas, the areas depicted in the pictures, one which is sub-rural and the one within an urban environment. And they will be collecting connected vehicle data, trying to understand pavement condition analysis from the sensors on the data, of course. They will integrate an accelerometer in their environments, and they will be understanding that if multiple vehicles always slow down at a particular place on the street, we can understand that the street, it has that the pavement or the infrastructure has some damage there. This is what the slide means with that. They will try to enable real-time infrastructure diagnostics via 5G network streams. It will be prioritizing maintenance zones using vertical vibration profiles from the sensors on the vehicles, and they will be exploring bidirectional data flows for driver risk notifications. This means that the driver will be having a mobile application, something like that, that will be sending notifications to them. Attention, you are going near an area that has some damage. We have the Santa Oliva pilot. You can see it. You can see a photograph from a satellite here. It's in Santa Oliva. There is the second organization whose logo you see in the slide, IDIADA. They are a big organization, and they have a private campus, let's say, there where they are testing. They are testing their products and their research artifacts, and that big campus, like it's very big. It's like a university campus with various roads to perform their tasks. And these roads they are being used daily by their employees and by their visitors, and they would like to actually deploy something that it is of actual value to them. Excuse me. They will be trying to assess how they can make those roads safer, let's say, across the facility, and how they can also make their employees, for example, have a small application on their phones that says, pay attention to this area because today it has snow, or because we have detected that animals have been crossing there and it's blocked, or it has an issue. So officially, they will be deploying multi-sensor roadside units for hazard detection. They will be attempting to detect debris, fog, and animals with AI-enhanced LiDAR. They will be using synthetic data to train their data models. So this is a technology that serves their technology, let's say. They will be integrating roadside feedback displays for dynamic nudging, and they will monitor infrastructure status through low-cost edge systems that they will be deploying, and they will be, I think those will be provided and co-tested with the other organization that you see there, Eureka. Then we have Alba Iulia, which is an historical city in Romania. Alba Iulia has chosen some particular intersections in their city, known by the municipality to be a little more dangerous than the average road, where supposedly many accidents happen. And they will try to test technologies there that will be making those intersections safer. So they will be using the EvoRoads technologies to detect and geolocate infrastructure defects, for example, big potholes in the street, using drone and satellite imagery. They will be having an AI algorithm of their own that will be classifying potholes, detecting and classifying potholes. It's a visual detection algorithm. They will be integrating the digital twin provided by the project with municipal GIS infrastructure. This is already something that the municipality has integrated. They will support predictive maintenance through remote asset monitoring and facilitate citizen-informed alerts via crowdsourced inputs. And last but not least, we have Riga in Latvia. They will be trying something different. They will be having scooters and and for those scooters they have developed, let's say, a kit. Imagine a box that has some equipment on it that has sensors. That has the it will have also, I think, a Raspberry Pi mounted on it, so they can have data collection and data processing. That's the word I was searching. Data processing on the edge. They will be using little cameras that will be mounted again in front of the scooter, and they will be taking photos of what's in front of the scooter. And if the algorithm detects on the edge that there is danger in front, they will be notifying the user, but they will be also send this information to the infrastructure management team of the municipality to decide whether they would like to send a crew there to repair the damage. So officially, they will be fusing they will be leveraging, as I mentioned before, sensor data, accelerometer and camera data. They will be detecting pavement anomalies using the algorithm that will be running on the Raspberry Pi. They will be sending those events, as sent before, with geolocation tagging, and they will support EVRU-focused planning via macromobility telemetry. Telemetry is all information gathered from the sensors I mentioned before. Let us see now what we used. I have been using the word. Let us see time. Okay, I have been using the word living labs a lot. So you might, if in your projects you have not seen this term before, you might be wondering what is the difference of a living lab as opposed to the traditional pilot that I know from other projects. Let us see first the official and ideal approach of the methodology of having living labs in order to collect user requirements for your project. And then let us discuss what are the challenges and some lessons learned on what from the EvoRoads project on how maybe we can a team that faces the same issue can bypass them, let's say, or can tackle them in a way that they still get some benefit from holding them. The normal pilots are in fact, as you already know, they are a testing site, actually. They are very predefined. They are some structured experiments where where scientists and research teams gather to test some particular technologies in a very specific scenario, see what goes wrong, what goes well, and then go home. And this is the pilot. Pretty much common standard research procedure, as opposed to the living labs that are centered around a community. Their purpose is not to be a very static and particular place and point in time where you will just be doing an experiment and then wrap everything up, but they are trying to build across time a community that reconvenes and discusses the problems, and where somebody that would like to test their technologies, where they can take some inspiration, then they can come back and demonstrate their early results, get some feedback, then again return again, more like the agile development process that you might know from software engineering. Pilots, of course, have a limited stakeholder involvement. More or less, technologies come and say, okay, I have this and this technology. Are you interested? If you're not interested, okay, this is what I'd like to try, at least. As opposed to the living labs, where those ideas are come through the involvement of many different stakeholders. You gather people in the room, you hear their needs, you think, you first you study their problems, you discuss it and rediscuss it, and then you finalize and crystallize what you would like to test and try in order to address those particular technologies, and not something that you have in mind and you decide that it might be interesting to try. As I mentioned before, pilots have a very fixed scope and duration. As the living labs, it's a more open and adaptive thing. For example, in the context of Eurovision European research project, you might have those living labs become like a living organization within a community, within a municipality, and those people can convene even after the particular project has ended, because they have found they found some business value in it, or maybe some technologies after the project ends, they can come back to this community on their own accord and ask some additional feedback or additional information. Pilots have a very fixed time frame, while the living labs are very long-term initiatives, as I mentioned before, beyond the project's official duration. Pilots have a limited regulatory impact. They are more like experiments. They are not so extroverted initiatives, let's say. Of course, you report to the European Union and to whoever funded your research about your results. This is not negotiable, but they do not serve as regulatory sandboxes, which is the case with the living labs. The living labs, as which are longer term initiatives, they can also serve in that direction, because they are extroverted by nature. You can invite a variety of stakeholders, and among them there can be, of course, regulators and people from the state and the municipality, according depending to what you're trying to do. And finally, pilots have limited applicability. You're developing something in a specific context, you test it, and that may be very tailored to where you are testing, to the thing you are testing, and you can be satisfied with it, because your need was not to transfer the results into something else. You wanted just to try your technology, and you are okay. While the living labs have the aspect have the aspiration, let's say, to be a test bed where let's say a minimum viable product can be developed, and that can be then transferred also and copied to other pilot sites. You have some pilot sites that they are doing the blueprint, and then you take this idea and you replicate it into other sites. And of course, you understand the benefits of this and why the European Union finds this idea. I hope I have given you a little bit an idea on what is the difference between those two worlds. And just for you to have an example, okay, this is the living lab theory, but what am I doing? We are convening with the stakeholders and we are discussing what? There are many approaches. They can range from to hold some. You may, depending on your budget and your availability, you can book a hotel for 2 days and people come over, come and go, and you can have a formal big event. And you can have workshops. You can have people sitting on the same table and discuss and stuff like that. You can have a buffet. You can have, I don't know, gift bags, you can have whatever you like. But you may also want to try another approach, like having a webinar, like have a virtual discussion, or taking 2 or 3 stakeholders, having multiple across different days with different stakeholders. Or you can just, like maybe my favorite approach, to take 2 or 3 people with a coffee in hand and walk in the city and discuss about the problems of the city while you are looking at them in front of you. Maybe this is the more casual approach, let's say. What do you discuss in order to collect user requirements? Nothing different from what you normally do when you're developing, what you're doing in software engineering. You're discussing who are your users, what are their roles, their responsibilities, their goals in their work, their interests, any particularities that they have as individuals and as people, but also as professionals, the critical requirements, what they need to succeed, the problems and challenges that they face in their not their lives in general, in their professional lives, and maybe barriers of other kind, like legislation, people, things that can only be told by the professionals that work on the sector and face them every day. And of course, they can also provide you during the discussion some ideas on what type of a system or software or hardware would be working for them. But the concept is not to have them say, I need a form with three boxes where I can type this and that, and this is a number, and this is a string. No, this is not the case. You need to collect in a more high level their needs at the first. You need what you are doing actually is profiling of your users, and this is what living labs are about. And of course, at the end, you use the same living lab to demonstrate what you built after this discussion opened your eyes, and get early feedback, and then maybe get again feedback and correct things and test things and measure things. But this is the ideal situation. Was this like that for us? I will tell you. I will tell you no. You have when working in real European Union projects, you have you have partners that have a budget limitation, that have human resources limitations, that they say, I do not know enough people in my community to start organizing mega events and closing hotels and booking hotels and booking catering and stuff like that. A very important success factor is the expertise of the facilitators of the discussions. They have to be experienced business analysts, to be honest, in order to be productive and lead the discussion towards getting useful insights and not just throwing people, feeding your audience on what you would like it to see. Of course, you can have some kind of bias. I mean, if your pilot leaders have not understood 100% at the time of the proposal what it was expected for them, they may be say, oh, okay, I came to this project to test this technology. There, I have planned it 100%. What are you talking to me about? I do not want to go and be extroverted and have. You may face this challenge. And of course, the availability of stakeholders. They might only have contacts in the municipality, let's say, but not know the average people on the street. They do not have contacts in other groups. Those challenges, of course, we faced everything, all of them in EvoRoads, but I think they are global when you're trying to implement the Living Labs approach in European projects. And to me, what I learned and what I think that it is very important is to take those limitations very seriously, to listen to people, to your pilot leaders very carefully and sympathetically, because they are very very serious approach. I mean, you cannot push your pilot leader to go over budget or to do something they have not invested person months to do. But the important thing is for you both to sit on the same table and have an open discussion with the little ingredients, let's say you have, the limited ingredients, what you can do as much as better as you can to have at least to have the best result possible. The one has to agree to downscope a little bit the ambition of the living labs, while the other one has to get a little bit outside their comfort zone. You can find middle ground, and that worked for us. So the workarounds would be to replace some big on-site meetings in hotels and big conference rooms. You can scale it down. You can say you can have a virtual workshop with stakeholders. You can have multiple small with limited people. You can hold recurring meetings to maintain engagement with the same people. You have to accept that the meetings are not too brief, of course, because if they are just 10-minute phone calls, you're not doing living labs. You're just checking the box of talking to people for the European Union, which is not optimal. I mean, you have to show that I took this seriously, right? And to hold, and another approach would be to hold additional consortium-only meetings. This is something that we did for user requirements between the pilots and the technology developers, because we needed results early for our deliverables, and we could not, in order to start writing the deliverables and working on technologies, we could not wait for the whole process to deliver the first round of technologies. Let us see how we are on time. Okay, let's see. Let's say that we have time only for the safety criteria catalog. Okay. Okay. The safety criteria catalog, it's one of I think it might be of interest to you and your project. It is a tool, let's say, that it is open to everyone, because it's a bibliographical research that you can just read the two documents, the two deliverables, and you can use it because the deliverables are for free. It's work that we have done for you and might be useful to you. Like we have open sourced, let's say, some code. So you might find it interesting. The concept is simple. The execution is difficult. A team of our colleagues from Fondazione Links has worked very, very hard analyzing legislation across countries of the European Union to collect a very big table of the safety criteria that matter, to put it simply, of the criteria that you can use on a system, on a technology to quantify and to measure what is the before and the after, to make comparisons, to understand what is important to bring actual value to your developments and to your approaches and your projects. And they have created in practice, they have created a matrix of 124 road safety indicators. They have grouped them in 10 categories, 10 transport dimensions, if you would like. And as I mentioned before, this is coming from a state-of-the-art review of regulations across many European states, not only the four that we show in our pilots. This is how it looks like. Of course, my screen does not have room for 124 criteria. You see, for example, accessory signals, the presence of adaptive and smart traffic signals, etc. Of course, those are analyzed in the document very analytically, what they are and where do they got them from. This is let's say, the summary at the end, the collection of, in a more readable form, of what is important to wear. So you can use this as a summary. While doing this bibliographical work, they saw that for the challenges that they identified as challenges, that there is a significant overlap or partial intersection in those 10 categories. So they had to engage in an in-depth discussion to do this grouping. To do this grouping efficiently. There is a wide variety among the 10 proposed categories, and some were less relevant in the end to what they were trying to do. The number of KPIs was great, 124, and then there was a second iteration, so they had the chance to enhance it. So this made, you understand, it was difficult to even write the deliverable at the end of the day. And what the lessons learned from that is that the analyzed countries generally adopt a safe system approach, and they emphasize vulnerable road user, but still gaps remain in standardizing new tech in order how you can approach it to validate it and assert that it really matters. Research and harmonization is still needed, and it's a process that does not stop because new technologies rise each day, and there is continuous technological advancements, and this continuous advancement requires, which is not new to you, adjustment of policies every time, and this not every time, but in let's say in recurring intervals, which poses a challenge in itself because adjustment of policies can take a long time, and legislature and propositions. There was, as I mentioned before, a second iteration where they identified missing metrics. They found missing metrics, and they added the second iteration was the approach for the second iteration was the following. They took information from the living labs, from the co-creation activities, and second, they released their initial 124 aspects catalog. They have posted on the internet, and they created the feedback questionnaire that it was addressed to people, that it was addressed to stakeholders, to safety, to road safety specialists across many sectors, not only people from information technology, but also from all the aspects of road safety. And through those, they identified missing metrics. They identified they received. They understood, let's say, that it was important to consider local context factors and not make generalizations about your criteria, because there are various differences from area to area, and they noted down also some qualitative considerations. As the slide says, suggestions were made to augment purely quantitative metrics with qualitative assessments, for instance, an evaluation of the appropriateness and effectiveness of road markings and signals. So not only quantitative considerations, but also qualitative. And these are,
right.
It's the last slide of the safety criteria, so I'm leaving there. I'm leaving there just for a second if somebody wants to scan the document. This is where our two documents are. The first is the big criteria catalog for somebody who would like to use it. The next is whatever you saw today, the requirements, the pilot approaches, what we did with the safe labs. So you can download Okay, I'm leaving this. I will be keeping, Julie, the next slides they were about the technology highlights and the architecture highlights. In case somebody does a particular question on those, I will just go to the corresponding graph. So I think, can we open the microphone?
The floor.
See your faces.
So let's take some time for questions in case there's any for Angelina so far. I haven't seen any question posted. If there's nobody that has an urgent clarification to be asked, and we can already move on to the next presentation. And of course, we can go back to EvoRoads presentation or approaches, questions to you, Angelina, later on, if it comes to people later in the discussion. Okay, then.
Thank you very much for your attention. See you a little later.
Thank you. So then let's go back, or let's go to our next presenter for iDriving. So Dr. Alexandros Sfiridis is a postdoctoral researcher at the Information Technologies Institute of CERT, so the Center for Research and Technology, ELAS. And as I was saying, he will be presenting similar information for iDriving, an introduction about the project first, and then on their progress so far, especially in relation with requirements collection. Alexandros, I let you the floor.
Yes, hello everyone. I hope you can hear me and see me well.
We can, yes.
Okay, let me share my screen. Just a second, please. Yeah, is it okay?
Yes.
Okay. Hello. Thanks for the invitation to this workshop. I will start by introducing myself. So I am Alex. I have recently joined CERT, that's the National Center for Research and Technology in Greece, as a deputy coordinator and technical manager for the iDriving project. CERT is leading this project and it's responsible for the whole management and coordination. So I will start with proceeding to the presentation, starting with some first basic information. So iDriving stands for Intelligent and Digital Roadway Infrastructure for Vehicles Integrated with Next Generation Technologies. It is, of course, a Horizon Europe funded project by the European Climate Infrastructure and Environmental Executive Agency. Quite a big project with a budget of about 5 million euros over the course of 36 months. So the project officially started last July and is scheduled to be completed by the end of June in 2027. So we're currently actually in month 12. So yeah, the consortium consists of 17 partners from 9 EU plus 1, that's Switzerland countries. And we have a quite interdisciplinary team with people from different backgrounds, experience and expertise, mainly skilled in several aspects of road safety and traffic management. And as you can see, all the involved partners cover a wide variety of public entities, research institutes, not-profit organizations, and MSCs, SMEs, sorry. So what started iDriving? So overall, if you see it past research and projects implemented, overall, it's quite common and easy to find historical data related to road safety or road conditions. But overall, we have identified that real-time data that could be quite useful are not available, at least not publicly available, so that people can have access and conduct related analysis. In addition, and similarly, the use of modern technologies like AI or extraction of data from several types of sensors and the utilization of this data, although it is something that is up and coming and starts to becoming widely used, still there is some limitation on its uses. In addition, road maintenance is reactive rather than proactive, actually. And of course, it is costly. And during the time where road maintenance takes place, we can experience disruptions on road traffic, etc. And finally, we have identified that there is inconsistency in safety standards across urban and rural environments. So here comes iDriving. The purpose is to utilize real-time data extracted from various sources and leverage advanced technologies such as AI, for example, to address these issues related to road safety and inefficient maintenance, so that the project per se can facilitate accident reduction and streamline maintenance in urban and rural areas. So essentially, what is the vision? The vision is to contribute towards making roads safer and smarter through the utilization of real-time data and advanced technologies, and overall focusing on transforming the road network. And from the vision comes the mission, where iDriving again aims to leverage rich and high quality, as much as possible, actually, data collected in real time and apply state-of-the-art technologies to enhance accident reduction, facilitate traffic management, and contribute to the improvement of road infrastructure overall by providing efficient and cost-effective solutions. But what are the specific project objectives? So to develop real-time road safety through monitoring and predicting road conditions based on AI data from different sensors and digital twins. Next one. Sorry. Next one. So focusing on road infrastructure to integrate UAVs, that's unmanned aerial vehicles, most commonly known as drones, mobile apps and similar technologies to enhance safety. So through risk analysis and dynamic maintenance planning, the objective here is to create efficient and cost-effective road maintenance strategies. We also focus on the safety criteria catalog for urban and rural roads, aiming to improving safety standards for all users. From our side, this is to be ready in the 18th month of the project, that is the upcoming December. And finally, provide real-time alerts and contribute towards the optimization of infrastructure to improve emergency response and associated traffic management. I'll move on to the use cases. So iDriving has 3 use cases across 6 unique pilot sites. Each use case has a different focus, and it's comprised by 2 scenarios. So the scenarios share similar objectives and motivations, but are slightly different, and this will be unfold across 6 different sides to some of the countries that are involved. In particular, we have some scenarios in Austria, France, Spain, Croatia, Romania, and Greece. So for use case 1, named enhanced login and user interaction monitoring for improvement of road infrastructure. So the motivation behind that is that, in urban environments, in particular intersections, we have high vehicle density leading to road congestion, and that in turn can lead to several traffic violations. Also, many drivers in urban environments, potentially because of low speeds in these environments, neglect the use of helmets and seatbelts, while in mixed environments such as urban ones, the many cyclists and pedestrians that are looking to use the infrastructure, but it's not adequate for them. So all these leads to potential safety risks for all road users, such as accidents or near misses. So the first scenario in Graz, Austria. The challenge here is the high vehicle density, so the focus is on cars and intersections, where, as mentioned, many violations may occur, such as vehicles in unauthorized lanes or driving in opposite directions or not paying too much attention to the traffic lights. We aim to use data from sensors, UAVs, or mobile apps to detect congestion patterns, helmet or seatbelt usage, or lane violations and traffic signal infractions. So actually the focus for this first scenario is on real-time detection of trespasses based on behavioral aspects, and provide alternative routes tailored to its vehicle type in order to avoid congestion, and also to collect and analyze data through the digital twin to identify congestion patterns and potentially also suggest infrastructure improvement. So we have also the second scenario in Nevers in France. Here, actually, there's more focus on the interaction among road users, and particularly focusing on active travel road users, so mainly cyclists or pedestrians. And the aim is mainly focused to capture potential infractions and risky behaviors, such as yielding behavior in zebra crossings, or cyclists signaling behavior like not raising their hand when they're about to turn or change lanes, or distractions for cyclists like using their phones while cycling, for example, but also looking at obstructions such as visual blocks by parked cars or vegetation. Again, the data in this case is about to be collected from UAVs or cameras, like street cameras or sensors. And yeah, that is actually, yeah, of course, and again, send warnings or in via the VMS, that's the vehicle message, that's the variable message signs, or through mobile apps to alert road users. So that's use case 1. Going to use case 2. So infrastructure maintenance and road monitoring for hazards. As the title indicates, there's a focus on insufficient and costly minor inspections on with regard to road maintenance, where many times we have potholes and other type of deformations of the street per se that can disrupt traffic and also lead to accidents. Of course, again, the approach is normally reactive rather than proactive. While we have in some secondary roads issues where natural obstructions or other weather conditions can affect traffic. So we have the first scenario in Karlovac in Croatia, where the focus is on infrastructure maintenance, where with the use of UAVs, we're looking to provide the 3D structural defect representation to actually save time and assessment costs when trying to assess the damage of the street. So the intervention is to schedule and plan maintenance to reduce long-term costs and disruptions through planning, and also provide alternative routes for vehicles by, again, notifying the public through VMS or mobile apps, and of course securing that the repair process would be efficient, cost effective, and also ensure road users like commuters and also workers' safety. So in the second scenario, that's in Thessaloniki, Greece, so the focus is the real-time hazard response in adverse weather conditions, like when we have heavy rain, winds, fallen trees, or rocks due to weather conditions, for example. Again, with the use of UAVs and data from weather stations, the aim is to conduct predictive analytics and issue warnings for road users in order to have an immediate response to potential ongoing dangers like hazards at the street level. Again, provide real-time warnings, alternative routing to road users with the aim to prevent accidents and minimize exposure to several road hazards. So that's about the use case 2. So essentially, the first scenario is more focused on infrastructure repair operations, and the second one is mostly focused on safety interventions for safety reasons, considering weather conditions. So then we have use case 3. Real-time incident prediction, detection, and response. So overall, this use case aims at enhancing road safety. So we have many behavioral aspects, such as drivers speeding or driving under the influence of alcohol, drugs, or whatever substances. Or for example, we have either other behaviors like risky overtaking, and all these may lead to accidents, collisions, and so on. So first scenario in Romania, that's in Alba Iulia, as in the EvoRoads project. So it's the same partner involved in both projects, but for different purposes. So if I remember correctly, in the case of EvoRoads, it was about road conditions, like the actual state of the streets, while in this case we're looking at abnormal behavior violations rather than road maintenance, for example. So the focus of this first scenario is proactive detection and warning for risky driving behaviors. such as speeding, driving under the influence of substances, and so on. So here again, we're using sensors and street cameras to detect abnormal behaviors and inform road users through, again, VMS or mobile applications, while also aiming to create heat map of the incidents to the potential road managers. So actually, the aim of this scenario is risk mitigation through analysis and alerts, to reduce the likelihood of incidents because of drivers' behavior. Then we have the second scenario in Vizcaya, Spain. I think that's the greater Bilbao area in the Basque Country. So the primary focus here is the quick response and emergency management in the event of collision. So real-time detection and collision management, actually. So again, with the use of cameras and UAVs coupled with signals from mobile apps or other sensors. UAVs will provide surveillance of this area to provide like a visualization, like a virtual representation of the accident scene. So the intervention here is on the response and coordination to alert the emergency services and manage traffic through rerouting and again providing alerts to road users. So essentially, the aim of this scenario is to minimize emergency response time, improve traffic flow, and document and analyze the incidents in the event of a collision. So I'm aware about the time, so I will very quickly go to the next slide. So the current status of the iDriving project is that we have designed the use cases. In terms of user requirements, we have extrapolated those a few months back through workshops that have been conducted in the sites, in the cities where the pilots are also going to take place. External partners and members of the public also participated through questionnaires, workshops, and discussions to identify the requirements. Currently, the technical requirements are ongoing while we're also preparing for the pilots. So again, this is our consortium. CERF is responsible for the project management and coordination, while the Technical University of Crete is on the scientific management side of things. And you can contact us through these very fancy QR codes. And there are also a couple of emails that you can use in case you need to contact the iDriving project as a whole. I'll leave it for a minute or so. Thank you very much again. And yeah, that was the presentation.
Thank you, Alex. So I'm asking the question again now. We have some time for Q&A. Some immediate question for Alex on the iDriving presentation. I don't know if any of you has a first pressing question. Everything clear? Like I said, you can raise them in writing, which the presenters have also access to, by the way, or raise your hand and to be given the floor. I don't see anything popping up at the moment urgent. So let's move on.
Thank you.
Thank you, Anix. I'll now give the floor to both Olivera Rossi and Despina Vounassis for the Camber project. So Ms. Rossi is Safer Journeys Regional Leader Europe at IRAP, and Ms. Despina Vounassis is Project Support Officer at the European Institute of Road Assessment. And I'll let you take control to share your own presentation now and give the floor over to you.
Thank you much,
Yes,
Julie.
hi.
I'll share the screen.
Thank you. Hello, everyone, and thank you for the introduction and all of you for being here. We are very happy to be here, so thank you for the invitation. As I said, I am Despina Vounassis, and I work at the European Institute of Road Assessment. And today, with my colleague Olivera Rossi, we will present the Camber project, which stands for Connected and Adaptive Maintenance for Safer Urban and Secondary Roads. This is a newly launched project that officially started in January 2025. So Camber brings together 14 partners from across of Europe, and we have 5 different pilot sites. So the solutions from the Camber project, which will be developed, will be tested in pilot locations, as you can see. So that's Portugal, Cascais region. We have Greece, Trikala region, Croatia, North Holland in the Netherlands, and Spain. So the main ambition of the project is to Olivera, if you could move to the next. So the main ambition of the project is to develop and demonstrate the solutions that integrate asset and safety management for urban and secondary road networks, and it aims to bridge the gap between infrastructure maintenance and road safety. So some of the challenges that we are aiming to address as the Camber projects, there are significant challenges because Europe has an enormous secondary road network, which is over 725,000 kilometers in total, and over 90% of traffic accidents and fatalities in Europe happen right on those urban and rural roads, and on the motorways we have only 8% of fatalities, and also one in every 3 victims are vulnerable road users, so pedestrians, cyclists, or motorcyclists. And those are the challenges that the Camber project is stepping up to address, because as you can see, we aim to eliminate all those traffic deaths by 2050. Next is so improving safety on high risk road networks. So next slide, please. So we have several components which we try to eliminate and to address those challenges through those components. So the first one is to eliminate duplication of efforts between stakeholders who are responsible for road maintenance and safety. We will also leverage new data sources to reduce the need for expensive and manual data collection, and we plan to connect all relevant data in one geolocated format to enable smart analysis and to target those interventions. And the Camber project will try to optimize the interaction between vehicle technologies and infrastructure to reduce the likelihood of the and severity, of course, of the crashes, and to identify low cost safety interventions to improve those outcomes of high risk networks. And I would say that those are 5 core components of the Camber approach for improving the safety.
And I will continue a little bit about Camber objectives by also reassuring that I'm really pleased to be here. We have 6 objectives in Camber project, and first of those is connecting infrastructure elements into the digital ecosystem. We will develop and test digital twins to enhance road safety management, safety, maintenance planning. Our pilots, we have 5 pilots, as Desmina mentioned, will use advanced data from sources like connected vehicle sensors, smartphone telematics, or road user reports. And we will also create a digital twin roadmap for wider adoption, supported by standardized data definition and specification for road infrastructure. Our second objective concerns safety performance criteria and its development. We are going to expand safety assessment methods used for roads to include new performance criteria and maintenance indicators that are specific to urban and secondary road, which was the overall objective of the call anyway. These criteria will, of course, consider all road users and will include specific for monitoring conditions safe for vehicles with advanced driver assistance system ADAS. The criteria will rely on a set of metrics for road safety and asset performance. These metrics will be optimized using data collected through the Camber pilots and integrated into current technologies. This will help identify cost-effective safety improvements and enhance tools for planning and prioritizing maintenance upgrades. And third objective is all about low-cost infrastructure measures. I'm laughing a little bit because we are discussing this a lot these days in the project. And it seems like everything is going around identifying low-cost infrastructure measures, which is really important, especially if you consider the size of the problem we are all addressing, but also the limited funding that exists at the moment, and also the trend in reverse trend in decreasing road injuries and fatalities. So in Camber, we will explore cost-effective road design improvements for safety, including rural roads, urban areas, but also we will look into the school zones. These measures like improved signal, signs and markings will target high-risk situation and vulnerable road users such as, for example, cyclists. Tests will be conducted in pilots using tools like driving simulators and on actual road to assess their effectiveness through video monitoring and vehicle sensors. Our fourth objective is kind of integration of data from different sources and different technologies in asset and road safety management. Of course, we will also look to improve support for automated driving on low ISAD level roads. This involves evaluating road markings, signs, signals, and other things to ensure they meet the performance standards required for automated vehicles. The project will use data from different driving studies, big data storage and processing, and IPAs to enable real-time and offline communication in systems. It's quite optimistic objective, and we are very much looking forward how this is going to fall into place at the later stage of the project. Our fifth objective is to discover and refine maintenance procedure and techniques which can minimize traffic crashes and have other positive impacts. And of course, we are going to produce guidelines Selected technologies will be tested with infrastructure measures and validated, and this is all going to be included in guidelines for designing, implementing, and maintaining road safety elements. And our sixth objective is what Despina mentioned, is to successfully carry out pilot project in 5 countries and 5 specific places, and adapt the solutions of the Camber that will be proposed in the Camber for different road networks. We are going to have really this secondary and urban network at the core of designs of what we are going to produce. These pilots will demonstrate how our project concept will work in real-world settings, and also activities will align with local goals and needs, offering a comparison to measure content cost and processes within current cost, and processes within the Camber approach. We are going to measure the success of the project using an evaluation framework that includes cost-benefit analysis and socio-economic impact assessment. Yeah, I think this is most in short about the objectives. How we organize our work, of course, as we all organize in work packages, and this is one thing, so how we work and how we think in terms of the project, but we also organize our work under the Camber components, looking into results, outcomes, and impact. And we will definitely work in terms of results on knowledge, products, and tools, creating digital twin interfaces and roadmaps, evaluation framework, which we consider quite important, research findings and safety optimized maintenance tools. Our outcomes will be increased knowledge, guidance and costing implementation, estimated impact of our activities into the European-wide implementation in case, of course, they are implemented, and so on. And of course, in terms of the final impact, the biggest keyword is safer roads, high confidence in decision making, streamlined and efficient maintenance, safer road conditions for all road users, reduction in fatal and serious injuries and crashes, and road safety targets met. We hope we are going to contribute at least a little bit to road safety targets that have been set by the Commission, and we have all referenced them in our presentations. In terms of deliverables, we are very at a critical stage, but the beginning of the project. Almost all our activities and tasks have now been kicked off. But we are just in the 6th month of the project implementation, so most of our current deliverables and those that will be delivered by the end of this month are related to project setting, project and all the procedures that should be in place, risk management, data management, and ethics management plans, project management plans, and communication strategies. However, closer to the end of the year, we are going to have our state-of-the-art and gap analysis and implementation and evaluation plan. When we approach next year this time, we are going to be much more mature about and identify data needs, pilots, be ready to talk much more in depth about pilot, like you did today, other projects, and so on. So I've just marked this deliverable in case this is going to be useful for discussion when these meetings can happen again, and when this is suitable for our project. So thank you very much, and looking forward for any questions if there are some, and of course into the interesting discussion, and we hope to be able to contribute with more content and in-depth analysis of what we are doing in the next meetings. Thanks a lot, Julie.
Thank you both.
Over to you.
Thank you both. I don't know, I mean, I'm asking the same question as I asked before, if there's an immediate question on what Camber just presented from the audience, from my colleagues from the other respective projects to kickstart. If not, maybe to kickstart the discussion between ourselves, I just wanted to ask you. I mean, we've all seen the presentation of the different objectives. Even some pilot sites are common and quite understandably because we all responded to the same call. So I just wanted to ask you, in case you would like to ask each other if precisely there's something distinctive from your project that you saw, or perhaps you want to ask that your project is doing that maybe is different from approach wise, or some different technology that you're focusing on that the other project is not. Just for the audience, or also for ourselves, to see if there's a distinctive feature between ourselves. I don't know if anyone saw this through the presentations or want to take the floor first. Or like I said, even if it's just a question to the others to say, to verify whether your understanding is correct or you saw something. Anyone?
I think it was quite the opposite, actually. They are very close to each other. Maybe we do not test the exact same technology or the exact specific algorithm, but more or less the objectives, they were very close. And maybe the expected artifacts, each of us had safety criteria catalog, for example, our set of technologies. I don't know, for example, what I would like to, maybe it's interesting to discuss. Our project has a big artifact, let's say, as a big output goal. It's also to disseminate data sets. We're preparing a big data space, let's say, safe roads data space. So to implement this, we had the need to become interoperable, to follow some standards, to explore how we can just not upload our, let's say, our data sets to a random repository on the internet. We needed to go in a more formal approach, maybe in technologically, just throw them to Zenode or something like that. So I would be interested to hear from Camber and from iDriving whether you had some similar obligation, or whether your data, there's not something like that in your contracts, and you are keeping your data to yourselves.
Yeah, if I may go for that first. So we haven't initially been thinking of like sharing data, for example. So, but of course, there's a lot of data being created through the whole project, and a lot of data being manipulated as well. So it's a good point of discussion, because I mean, myself, I kind of agreed to what Angelina said. I actually see loads of similarities rather than differences across these three projects. So I think that the data generation and data sharing is a good starting point for a potential collaboration. So what we have been thinking, I mean, although it's not like one of the main purposes of our project, we were considering that we could potentially share some probably anonymized sample data sets, or some kind like pre-trained models, for example, for research purposes, or for enhancing collaboration overall. Of course, I mean that depends on the context and the data, because we all know that there should be some GDPR compliance and so on. But yeah, I mean, we would be open and interested to discuss suggestions on specific data sets or models that would facilitate cross collaboration overall.
To give an example, you don't have to commit here, just clarifying my thought. For example, we had the need to train some algorithms to distinguish which road signs had damage. There are some open data sets on the internet. Okay, they could the teams that they were working on that could do their jobs with open data sets. But I think that if someone in our project or photographs of potholes, photographs of damages in the infrastructure that you can feed to a vision recognition algorithm and make it learn how to detect things in new when it receives new photographs. So I think that if there's those kind of harmless, let's say, from a GDPR point of view, data sets that are being used, and maybe they are common to all three projects, since we are all three looking for damaged infrastructure, that would be a good idea. There are several open data sets, but maybe we could say that, okay, as a community, we collected those data sets, we anonymize, we clean them, they are safe for use for research purposes, and we can publish them in a common repository and say those are from our cluster, propositions of our cluster.
If I may add to that, Angelina, but it of course very much depends on the timeline of the project, because we have started with a lag of 6 months, so this may affect the progress. I see, as we all see, a lot of similarities in the project, and we all address the same goal. So that is natural, but it's also amazing how many different kind of technologies we are suggesting and so on. But definitely in Cambridge project and for the pilots, we are going to collect ground data and also use IRAP assessment methodologies to have data that may be useful for you and for your training of technologies to identify different stuff. I mean, we can probably have a separate meeting on that at one point if you like. So we present to you what we have, what we plan to gather, and especially involve those partners who will be gathering data. So you see if there is something that could be really of a benefit for you. But first of all, definitely we will need to see the timeline and whether we will have this early enough for you to use.
But maybe here we're talking about pre-existing data sets, right? Angelina, you were saying
no,
something not necessarily collected within the project. It can be
also data sets, of course, and external ones, why not? But it can also be data that we eventually collect within the project and we would like to share with future researchers. So,
sure.
This does not have the problem of the timeline.
No, I understand what you mean.
The timeline, I think, benefits more Camber because they're a little bit behind, so they can use our data sets. So
yes.
This is,
but the other way around, for us to benefit, then what your question would be whether there are pre-existing one at this stage that our partners know or have access to, and that are free of use.
Maybe they can use in the EvoRoads project in the second iteration, in the second training of the algorithms, that's okay. But we can also use them for the data space in order to make it more rich.
Yeah.
To make it just more, to give more chances and motivations to outside researchers to share our catalog and see, okay, that I find more than just 10 data sets, that 20 data sets are better than 10.
Okay, is there
Yeah.
Go.
Okay, yeah.
Alexandros.
I just want to say that in any event, we can always arrange a meeting across the projects to identify everyone's needs and, exchange information, data, or anything that can be valuable for anyone. That's all.
That's a good point, and I don't know what you're thinking, Angelina, but we have an approaching General Assembly, and since it's online, maybe we could plan within the program a shared session with our two sister projects to discuss specifically those needs.
Sure, why not?
I don't know, Alexandros, if you have a question from iDriving. I mean, Angelina went from EvoRoads perspective. Do you have a question to EvoRoads or Canva from that matter?
I had some. Just let me check
Sure.
my notes, please.
Absolutely.
Allow me a minute. Yeah.
Or Olivera, you want to also go first? Oh, I see Nico is his hand raised. So either way, go ahead then, Nico, and then maybe Olivera if you have another one.
Okay. I was surprised by the Riga Living Labs in EvoRoads. You say that you are deploying scooter kits. I was wondering how that looks and if you're going to work with private individuals, or are you going to have a specific partner or partners that are going to implement this in their scooters?
There is a specific, I'm not muted, there is a specific partner that develops this kit internally. So it's not something that it was made just for the project. They are using the funding to develop this internally. So it's the company name is DOTS. They are the pilot leader of Riga. And I think Julie and I will be happy to share their contacts with you. I'm not sure if I have the clearance to show you a photograph. I have seen it in pictures because we've exchanged our during the meetings. I do not know if they would like the photographs to be shared or they are proprietary secret right now. But from what I have seen, they have the scooter, of course, and they have the kit is actually it's not just a box. It's a tool set. It's a whole box with a camera on top that they place on the steering wheel. That the camera looks down in front of the wheel of the scooter so as to record pictures in front of where the person is going with the scooter. Also, parenthesis regarding GDPR, one of the reasons the scooter looks down is the fact that down you can record only the faces of cats. It's not people. And then this kit contains a small computer, a Raspberry Pi, that has on board have all the sensors needed, the accelerometer, the GPS, everything they need for the data they are collecting and they would like to report. And it also has, they will be deploying locally on the edge the algorithm that analyzes on the fly those images and detects that the pavement is damaged, let's say. And they will be not storing locally or in the cloud each and every file and image. Most of the images are pavements who are not damaged, right? They were not saving everything, just some indicative pavement pictures because of we're talking about thousands of big data of images, so there is no space for that. What they will be recording on the general platform of the EvoRoads is the event of having detected a pothole. and efficiency. And they will be having and we attaching the picture, the estimation confidence that this is a pothole, the location, of course, and and the picture for. And this will be visualized through a dashboard to people at an office, let's say. That's the concept.
Is it what you wanted to find out, Nico? Is it clear?
Yes, thank you.
Olivera, because I asked you first, is there any other question you had in mind for either project?
Yeah, thanks, Julie. Actually, there are none or many questions, but we will definitely need to first of all digest. We are now at this phase where we can start thinking of our project and see how this links, but also digest both very interesting EvoRoads and driving projects. And I definitely agree with Alex about the data and data map, and maybe we could create something like a common document to write the data that each project may collect or will be collecting or may already have, because we do have, and this is to answer to Angelina and you on the previous, we do already have some data which we will use that may potentially be useful also for you. So yeah, I definitely see the good scope for another meeting, especially on data, but also on other topics. But data is something where we can easily collaborate, given that all varieties of technologies that we are using. But the data is, again, data.
Yes, Nikos, go ahead.
Hello, good afternoon also from my side. I'm Nikos Drouvas. I'm in the coordination team in high driving here in SER. Thank you very much all for your presentations. I think it were very fruitful. We have very fruitful details during the whole workshop here today. Something that I would like to initiate some discussions maybe, because I think it is interesting also for us, is okay, probably we all are in TRL6 right now. We are aiming at TRL6, I believe, as a result of the project. TRL6, as Angelina described very correctly previously, is okay, we have some pilots. We will demonstrate them in some relevant environments with the participants, with the consortium members, with the technical partners, etc. I believe that we all have some indicators, KPIs, not only technical KPIs, but maybe some impact KPIs to the open public, let's say, on how can it reduce, I don't know, accidents and this type of KPIs. So how do you imagine to solve this, let's say, problem somehow? Okay, because if we have, if we demonstrate these technologies in a close consortium or with some people, how we will say that okay, this will have an impact, a greater impact to the public, for example? Do you have any ideas? Or maybe, if not right now, maybe this is a topic for discussion also for the following meetings.
I think that we are, as EvoRoads, we are theoretically covered on that, I think, by the living labs approach. The fact that there is supposedly this co-creation concept that we actually do not. Some of our pilots, they're, for example, like the Santa Oliva pilot, which I mentioned, that it is a private company that is using the assets to the EvoRoads assets to test something on their private campus. It was the fourth I described. So yeah, this is a very closed environment. But for the others, for example, for the Turin pilot or the Romania pilot, they held several meetings with the municipality, with some local stakeholders. Turin was talking with a hospital in the area. I think maybe not all pilots were successful in equal measure in engaging external stakeholders, but I can say with enough confidence that we managed to also engage stakeholders and bring their feedback and bring their ideas, and maybe they changed in some aspects our perception. Because when you're a technology person, you dream big and say, oh, I want to build an AI thing that solves all the world's problems. But then your users come and say, okay, this is too much for me. I just need this little thing that will make my life 100% better. Can you do it or not? So there have been some discussions like that. So I think that was our approach, more or less. Then you have to say that you are not 5, that you are 6. You can do 2 iterations, I guess. You can have, I think most of the projects now include at least 2 iterations of validation rounds. Of course, in the first, most of the technologies are very mature, from my experience in various projects, but also maybe another approach would be this. Do you plan to do something different, something special regarding that?
Yeah, from our side, yeah, we're trying. It's not a technology restriction, let's say, because the technology will be there. What we face sometimes, so not only night driving, in the other project, is legal restrictions, ethical restrictions, the GDPR compliance, in order to measure, to monitor the congestion with other people outside the consortium, etc. This is the main issue that we face, let's say, sometimes. What we are trying also from our side is, of course, yes, we already have involved outside stakeholders, outside the iDriving consortium, either end users or traffic managers, in order, first of all, to take their feedback on the system, and of course, define these KPIs and how they will affect the general public. And of course, we are in constant collaboration with them in order to see, as you described, as a living lab after our pilots, maybe if somehow some of these tools, all iDriving as a whole, can be somehow adopted by a municipality or a specific traffic manager that wants these tools in order to measure also better the impact on the general public. So we're working on this, let's say, towards this path from our side.
For example, you mentioned that we have a common pilot in Alba Iulia. I know that the municipality already has an application, let's say, that leverages such data, and maybe you can integrate. You can try to integrate with that.
Exactly. Yeah, we're trying to do this.
If they are exposing some endpoints, or you could expose some endpoints for them.
Exactly. And we're trying also to present, yes, our technologies to other municipalities outside of the consortium, just to see also their interest and how they can adopt those technologies in their tools. Yeah, this is our approach on how we're going to measure somehow this impact.
And also, Alexandros mentioned before, and the interesting idea that you can also publish your models. And they're like in a platform like Kaggle or Hugging Face or something like that, where if you can adequately describe what type of data sets are needed, or even better, if you can also attach a data set or the link to sample data set, let's say, that they can use, and they can or plain GitHub or a notebook on GitHub. It does not need to be really complicated, and invite people to try it over time, of course, because they will not. The problem is you have to report within the 3 years of the project, but but maybe you can, some way, at least you can mention it in any workshops or dissemination activities that you have. Okay, we have this repository there with our algorithms. You can check it out.
Thank you very much. Yes, we agree. Yes.
I don't know, are there any other views from Canberra side, also from people on the line, which are also meant to be from our respective projects, not just our speakers? I don't know.
Maybe from Kemper, if I can add something to the current discussion without being really able to explain in Nico's terms how this is going to happen in practice, but we are going to develop in the project an evaluation framework. So all the Kemper interventions and solutions will be evaluated to ensure that they meet current and future needs that will be, of course, identified in the project. And this framework will include cost-benefit analysis and impact assessment to understand, and it's also going to elaborate on social economic benefits, as well as the potential impact of the solutions that will be proposed of these solutions, of the potential impact of these solutions if they are adopted at the European-wide scale. Don't ask me practically how we are going to do this, because it's very early to say something on that practically. But definitely we in the consortium do have partners who are dealing with impact assessments and these kind of things that can calculate these things, cost benefit and other stuff. And I think this is how this is going to happen. How, but not what will exactly this entail.
Thank you. We come to the end of this workshop, so I don't know if there's another question. Oh yes, there's somebody from Cinea, which I will unmute just a second. Voila, you can take the floor and ask your question directly, Ms. Deliali.
Can I speak? You hear me?
Yes, we can
now
hear
you
you.
hear me. Okay, now it's unblocked. Okay, so good afternoon, everyone. I'm Katerina Deliali. I am, as of quite recently, the project officer of all these 3 projects, and it's really nice to see the event and, to get familiar with what is happening. I don't want this, it's more an event for you to discuss. So, my role has to be a bit on the side to let you explore the potential synergies and so on. But I would like to stress a small thing for now, but I think it's quite important. And I really see that this is very well considered in Kemper project, but I'm not very sure how much is incorporated in the other 2 projects. The fact that we talk about urban roads and secondary rural roads. So all these solutions should really link back to this and consider the fact that essentially that's the majority of roads in European Union. The call is also asking for a reference, consideration, some sort of consideration of the TNT network. So it's besides technologies, but it's really important to consider that eventually you have these small pilots, these small living labs that test some technologies, but the idea is to think towards the end of the project how this could be scaled up massively to cover essentially the biggest networks of Europe. With all these ethical, legal considerations that Nikos is mentioning, and I know having an impact assessment for that, as Olivera mentioned, is really challenging. It has many assumptions, it has many parameters that in a 3-year project you cannot really cover and fully understand. But that's to keep in mind, to link back to these types of network. And what would be, because some technologies, let's say connected vehicle data, V2I and so on, have been tested to some extent to motorways in Europe, but now we are taking them to a different context. This is it, and an even smaller comment, because I think there is some concern about TRL. The call does not mention anything about TRL, technology readiness level. Generally, the projects that are RIA have a lower TRL compared to those that are IA. But, that's an indicator. In industry, TRLs are defined by ISO, so we're not going to do this right now. That's it. And again, thank you very much. I hope I didn't intervene a lot and let you discuss.
Many thanks for your comment. I don't know if one of the partners from the different projects want to give an immediate reaction.
Can I address the concern?
Yes,
Absolutely.
yes, of course.
Nice to meet you, Mr. Yali. And thank you for your
No, it's
comment and your
Katerina, please, no. Oh, no.
Thank you. Thank you, Katerina. Regarding the EvoRoads pilots, we indeed have a variety. The pilots have a variety of, they're not only in cities. For example, the Galicia pilot is a national road, national road N 50,000 or 50,050, something like that. It's a big, it's a road.
No, I don't doubt that they exist in the call, because if this didn't exist in the call, we wouldn't be here. It's just a matter of, let's say, the perspective. Like Camper, the moment you open the proposal, they have this statement. Europe has that many kilometers, and they started the presentation like this. So it gives you at least the impression, because, okay, then you have 3 years to realize the impression that that's, let's say, a core principle they follow. It's just the impression of how the presentation, and of course, a 15-minute presentation cannot cover the work done by that many entities for 3 years. I'm just pointing out what I see a bit as not so in the surface, to put it like this.
Understood.
I don't doubt that you have it in the, you have those areas and the specific road segments.
So in dissemination, you mean we must emphasize it much more?
Yeah, in dissemination, in practical things, yes, in finding the relevant authorities and network operators that care for these aspects, but also in impact assessment, I would say.
Thank you for this insight. It's important. I think we can. Julie is the work package leader actually with the task, the impact.
Okay.
So I think she will transfer it to the respective task.
I was thinking this is for me related to also exploitation, because you're talking about scaling up, and I know that the partners that are working with me and specifically responsible for these considerations are in the call. So I hope they listen very well, and if not, I will pass on your comment to them to make sure that that's a point of attention.
Okay. And then another thing, but that's on my to-do list, let's say, I will try to liaise a bit with the policy officer from DigiMove side that also prepared this call for the 3 projects, in case they have a better indication about the data. As you discussed, you collect all this data, how you share it. I don't know, probably it will be just an indication, but I think it's still good if I manage to find something relevant to communicate this to you. And here I stop talking.
Thank you.
Okay.
We very much appreciate the
Thank
comments.
you very much for everything.
And the support. Okay, I think we came to the end of the discussion. It's clear that we have many other questions for each other. As pointed out, this was first and foremost a useful exercise for the 3 projects to get acquainted with the work in the respective projects and start thinking about indeed how we can best collaborate, what aspects would be most useful to collaborate on. And I think that this is the first of a series of discussions that we're going to have from now on, at least to establish the dialogue, as I was saying at the beginning, to continue exchanging on the progress, on the technology, on anything that is required across all 3 projects. Then we can benefit indeed from discussing and finding it out all together. So as also presented, there are upcoming next results across some of the projects. I mean, we heard also from Cumber that they will follow a bit later. But so I think that we can already say that there will be also more of these open webinars where we can mutually present our results. And we will keep in touch offline to already fix the next discussion to continue this dialogue started out today, and perhaps have the opportunity to ask some more of these questions with our respective consortia present. Anything else that you speakers from the 3 projects partners in the call would like to add as a final consideration? Thank you very much for your participation and the presentation. I mentioned it in the comments, I hope everybody saw, but we will share this material at least on our website. I suppose the other projects will also relay this. And please, members from the project, please expect a follow-up email, especially from our side with Angelina. I would like to very much to then set up a next appointment very soon to continue the dialogue on the requirements from the respective projects where we can support each other. Yes? Then this closes the workshop. Thank you very much. Thank you for listening in, and let's continue this collaboration that hopefully we started up today.
Thank you
Have a
very
good
much.
end
It
of
was a
afternoon.
pleasure.
Bye.
Bye.
Thank you very much.
Bye.
Cheers. Bye.
Thank you. Bye.